Welcome back for another flight computer video on the DR2 Dreieckrechner. This is the third video. In the first video, we took a look at how to solve wind triangle problems using the law of sines. In the second video, we took a look at the gauge markings and the computations that could be done on this side of the device. And we left only one mystery, which was that the Dreieckrechner has this strange pin here at 7 minutes that the cursor can easily lock into. Now, I should say not all DR2 flight computers have these. The early models do, and the later models apparently replace this pin with a gauge marking. So the question is, what is so significant about 7 minutes? If you think about aviation and all the things that we do, what involves 7 minutes? Well, nothing anymore. You might think, well, perhaps it's for a holding pattern, so that we can time our legs to 7 minutes. But a 7-minute leg on a holding pattern would be a pretty long time to go in one direction. So according to some scholarly writing on this device, 7 minutes was used for the final approach leg of an instrument procedure in the early instrument procedures in the 1930s and 1940s. And this procedure was known as the ZZ procedure. And in order to explain what 7 minutes is all about, we'll just take a quick look at what this procedure did. So in a ZZ procedure, an airplane would be flying along in the clouds. They would call an airport, and we'll say that the airport is at the center of this plotting circle right here. And they would, through radio direction finding at the airport, report to the airplane what the bearing to the airport was. So in this case, it would be something, they would report bearing 333 degrees to the airport. The airplane would then turn inbound, fly to the airport, and when arriving over the top of the airport, which would be by hearing the sound of the motor, then the airport would report to the pilot to turn outbound for the procedure. Now, the pilot would then fly outbound for a certain amount of time such that when they do a 180-degree turn, they would be 7 minutes away from the airport. Now, this is not a fixed distance, so if we had a no-wind condition, then we would just fly outbound for 7 minutes and fly inbound for 7 minutes. But if we have any sort of headwind or tailwind component, this is going to end up shrinking this procedure down. So in terms of distance from the airport, which is quite foreign to the way that we do instrument approach procedures today. So what would happen at each one of these 7 minutes then is the airplane would transmit on the radio, the station would take a bearing and report back to the airplane within that time frame, whether they were left or right of course. So on the minute, the airplane would transmit, and then for the second half of the minute, the station, the airport, would then tell the airplane, all right, you're left of course, you're right of course. And this would repeat until they were established and could descend lower and lower and lower and actually arrive at the airport. So what this 7-minute pin is trying to do for us is tell us or help us calculate our time to turn. And to see that in action, let's go ahead and do a problem. So we'll say that the wind is coming from 250 at 47 kilometers, and we are outbound. We'll say that we're flying outbound to the west. So we set our airplane to the west, we set our wind, and we end up with our we're going outbound to the east. Getting ahead of myself. Outbound to the east, and the wind is coming here from 250, and that gives us our first relative wind angle of 160 degrees. So our relative wind angle on the way out is 160. And then our relative wind angle on the way back in, let me just flip this around. Now we're pointing to final approach course, 270, and the wind here, the relative wind angle is 20 degrees. Now, our next job is to figure out our wind correction angle. So we go to the front side of the device, and what we want to do is set up our relative wind angle, we'll do 160, over our true airspeed, which is 185. So here I'm setting 185 over 20. And notice actually that, or 160, that both of my relative wind angles are in the same location on the scale. And that's because the wind correction angle is actually going to be the same whether I'm inbound or outbound, but what will change will be my ground speed. So let's find out what that wind correction will be. To do that, we look across from our wind velocity, which is 47 kilometers per hour. And that gives us our wind correction angle right here of 5 degrees. So that means if we were flying outbound on a heading of 090, we would have to crab into the wind, and we would be flying a heading of 095. And likewise, when we turn around and fly 270 back inbound, we'll have to be holding a wind correction angle of 5 degrees to the left, or 265 is our final approach heading. Okay, now the next thing to do is to find out what our ground speeds would be, so that we can figure out how long our time to turn is going to take. And to do this, what we would do is subtract our ground speed, or our wind correction angle, from our relative wind angle. So we had a relative wind angle on the way outbound of 160, and when we subtract 5 from that, which is our wind correction angle, that brings us over here to this angle of 155. And this would be our ground speed on the way out, which we don't have to calculate, but it'd be just under 230 kilometers per hour. And if we wanted to calculate our ground speed on the way back in, well, that would be 20, our relative wind angle of 20 degrees minus our wind correction angle of 5, which would put us here at 15 degrees on the sine scale. And that gives us our ground speed on the way inbound, which would be about 140 kilometers per hour. Okay, now what about this magic pin 7? So in order to solve our time to turn, what we do is we take our cursor, we click it into 7 minutes, and we put 7 minutes on our outbound speed here. So our outbound speed was 25 degrees on the sine scale. This is our relative wind angle out minus 5 degrees, or 155 degrees on the sine scale. Once 7 is aligned with that, what we've done is we've come up with a scaling of time here. So if we look over our relative wind angle inbound here at 15 degrees, that tells us the equivalent amount of time to fly that leg at that slower speed, which would be between 4 and 4.5 minutes. And it looks to me like it's 4 minutes and 20 seconds. That's some pretty complicated math, but I hope it's a clear example of what this 7-minute mark was supposed to do. Taking a look at trying to fly outbound for a certain amount of time so that we knew when we flew inbound, we would have 7 minutes from our turn to our destination. That was the goal. And by putting a pin here at 7 minutes, that allowed pilots to make that calculation relatively easy by just lining up the cursor with the locked pin directly on our outbound ground speed. So that concludes our videos on the DR2 Dreieckrechner. Hope you've enjoyed them. If you're interested in other flight computer videos, come back and check out this channel anytime. Thank you very much for watching.